Okay, so let's do 12b. And we have the following equation, the following function that we want to graph. F of x is equal to 3x to the fourth. Just a minute. 3x to the fourth minus 20x cubed plus 36x squared. All right, and we can factor out from this an x squared, and we have 3x squared minus 20x plus 36. Now if we want to check out the x-intercepts, we'll be setting this equal to 0. And so we see that we have, from this factor, we have x equals 0 as an x-intercept. What about from the second quadratic factor? Well, you'll see that you won't be able to factor this, and also in this case b squared minus 4ac is less than 0. That is, the discriminant is less than 0. So no zeros coming out of this quadratic, so only the x-intercept is x equals 0, and that's the y-intercept as well. Alright, so 0, 0 is the x-intercept and the y-intercept. Okay, let's talk about the end behavior. Well, the leading term is 3 times x to the fourth. So as x goes to plus or minus infinity, we have f of x growing to infinity. Okay, let's look at f double prime of x now. Okay, so that was, I'm sorry, let's look at f prime of x now. That was f of x. Now let's just do f prime of x. Okay, looking at the unfactored form, I'll take the derivative. So that's 12x cubed minus 60x squared plus 72x. Alright, we can factor out 12x from this. And here we're left with x squared minus 5x plus 6. Alright, now this factors into x minus 3x minus 2. So here we have critical values. We have 3 critical values. X equals 0, 3, and 2. Alright, so let's do a plus minus analysis. And we have 0, 2, 3. And when we do a plus minus analysis, we have positive in this interval, negative here, positive here, negative here. So our function is decreasing, increasing, decreasing, increasing. So we have a min at 0, 0. Okay. We have a max at 232. And we have a min at 327. Okay, we get these values by substituting 2 into the original function into f of x. This is f of 2. And this is f of 3. Okay, now let's look at our second derivative, f double prime. F double prime of x. Okay, go back to the unfactored form of f prime. Maybe we'll just factor out the 12. And we get f prime of x is equal to, we have 12x cubed minus 60x squared plus, sorry, that's f double prime. Let me do f, I was just rewriting f prime of x over there. Okay. F double prime. Alright. f double prime. All right, if we factor out 12, it'll be easier to calculate f double prime. This is 12x cubed minus 5x squared plus 6x. Alright, so for f double prime we have 12 times 3x squared minus 10x plus 6. Okay, 3x squared minus 10x plus 6. Alright. Now, here if we will have a hard time factoring, but we can use the quadratic formula. From the quadratic formula, we get that the roots are negative b, that's minus 10, that's plus 10, plus or minus the square root. B squared is 100 minus 4ac minus 4 times 3 times 8 minus 4 times 18, and that comes out to 28 over 6. The square root of 28 simplifies, that's 4 times 7, so we can bring out a 2 root 7, and then divide top and bottom by 2. So here this simplifies to 5 plus or minus square root 7 over 3. Alright, so those are, we'll see that those are inflection points. Alright, so if we do a plus minus analysis of f double prime, over here we have 5 minus root 7 and 5 plus root 7 over 3. And if we do our analysis, we'll see that we have a positive interval on the right, negative in the middle, and positive on the left. So here the graph is concave up, down, and up, and these are two inflection points. Alright, this value over here we approximate as approximately 2.5, and this value here is we approximate using a calculator. This is approximately 0.8. So if we substitute these into the original f of x, then we have for inflection points 0.8 and 1.23 and 2.5 and 29.7. And finally we can draw a graph putting in the information that we have. Okay, first of all, our x and y intercept 0, 0, which was also found to be a minimum. And then we had the maximum at 2, 32. Let me put 32 up here. So we found that that's a maximum. Okay, we found end behavior going to plus infinity on both sides. We also had a minimum at 327 up here somewhere. So that's the minimum. And then we had an inflection point at approximately 2.5 in between here and 29.7. Approximately over here we had an inflection point. And another inflection point over here, 0.8 and 1.23, so down here somewhere. Okay, and nothing else happening to the left. of 0. This just increases to infinity, and let's connect to that. This also increases to infinity. This is the inflection point at 0.8, and 1.23. Okay, and that's the graph.